Okay, section 11.2, graphing hyperbola. So this is the last conic section we're going to learn, and this is the last lesson we're going to learn for the whole year. Woo! Okay, congratulations, you almost survived junior year. Okay, so like I said, the last thing we're going to graph is a hyperbola, and that's the set of all points whose distances to two fixed points, so we know those as our foci now, have a constant difference. So an ellipse was a constant sum. Okay, so we were adding my x squared and my y squared together. Now in a hyperbola, we are subtracting those two. Okay, and the center of our hyperbola is also the halfway point between our foci, just like the ellipse. Okay, it's kind of like two parabolas repelling each other. Okay, that's what a hyperbola looks like. So the standard form of a hyperbola takes on two forms. So a hyperbola could either open left and right, okay, so like repelling your y-axis, or they could be opening up and down, so like repelling your x-axis. So it just depends on what's being subtracted. So with our ellipse, our A and our B used to be able to switch positions like underneath the x and the y, right? Sometimes the A was underneath the y, sometimes the A was underneath the x, and that kind of determined which way our ellipse was getting stretched. It was either getting stretched along the y-axis or it's getting stretched along the x-axis. Well, a hyperbola is a little bit different. The A is always going to be underneath the x, and the B is always going to be underneath the y. Okay, so it's not really interchangeable, but what is interchangeable is the order. So now if the x is subtracting the y, okay, it means it's moving away from the y-axis. So it's opening up from left to right. So in this graph right here, here's my hyperbola. These two kind of repelling parabolas opening left and right. Okay, so they're kind of repelling this y-axis right here. And then notice how this one's a little bit different. So I'm subtracting the x instead of subtracting the y, and the A is still underneath the x. So I'm not switching the A and the B, I'm just switching the x and the y. Okay, so now my parabolas that are repelling each other, my hyperbola is going away from the x. So we're subtracting the x, my hyperbola is going away from the x, so they're opening up and down. Okay, so here's some examples. So in example 1, I have x minus y. So remember, your A is always underneath your x, and your B is always underneath your y. And we're not going to focus on the foci with the hyperbola. Okay, I was going to go into it, but I feel like it's a little bit too in-depth, and it's kind of a lot to explain over a video when I'm not there with you guys in person. But trust me, when you get into senior year, that will all be explained to you. I'm just going to kind of dumb this down a little bit so it's a little bit more simple to graph just by solely learning from this video. So in number 1, I first want to identify my center. So nothing's being subtracted from the x and the y. So I know that my center is located at 0, 0. Okay, so whatever is underneath your x is how far you're going to move along your x-axis from the center. So I know that this is a squared, so a is equal to 4, right? You just take the square root, just like an ellipse. And to get b, I'm going to take the square root, and I get 3. Okay, so what I'm going to do is I'm going to plot 0, 0, because that's my center, and I'm going to count 4 along the x-axis. So 1, 2, 3, 4. I'm going to put this point here. 1, 2, 3, 4. I'm going to put this point here. And I'm going to do the same thing, but along the y-axis. And I got to count 3 up and down. So I'm going to go up 3, 1, 2, 3. Then I'm going to go down 3, 1, 2, 3. Okay. So from here, you need to create a rectangle. Okay, And the reason why I'm doing this is because I need to create asymptotes. That's going to guide me into creating my hyperbola. So let's kind of talk about, let me go back really quickly to these diagrams. See these dotted orange lines right here that are going through your center? Those are called asymptotes. Okay, let's actually label those. And asymptotes kind of act as a guide for your graph. So your graph is going to go along the asymptote, okay, but it never, ever, ever crosses the asymptote. So it's just a guide for your graph to kind of see how it's going to go, but your graph is never going to cross through that asymptote. Okay, so I'm creating this rectangle. You could kind of see it in these diagrams through those points that I created. Okay, and now your asymptote is going to go through the center and the corners of your rectangle. Okay, so I'm going to draw lines through the center, through the corners of my rectangle. So I'm creating a diagonal through the rectangle, and I'm going to do it the same way on the other side. So it's got to go through the center and then through the corners of the rectangle. Okay, so now this is where it's important to know, does my graph open up and down, or does it graph left to right? Because that's going to determine which one's actually my vertex. Is it the dark green dots or is it the purple dots? Well, let's look. It's subtracting y. So it's kind of like my hyperbola is repelling y. So that means it's opening left and right. It's repelling the y-axis. So when I draw this, my vertex is going to be these points that I drew right here, and my graph is going to be guided by the asymptotes that I just created. So I'm going to draw this hyperbola, or this parabola looking thing, along the asymptote through the vertex, and there's half of my hyperbola, and I'm going to do the same exact thing on the other side. So I'm going to use my asymptote as a guide, and it's going to go through that vertex that I created, draw my arrows, and so the dark green is actually what the hyperbola is. Okay, it's not the asymptote, it's not that rectangle. Okay, it's those dark green lines, and since it's opening left and right, this is a vertex, and this is a vertex. And this point is at -4, 0, and the other vertex is at 4, 0. Okay, my center's at 0, 0. And that's essentially it. Okay, I kind of think this one is a little bit easier to graph. It's pretty quick. So for number 2, I don't see anything being subtracted from y or x. So I know that my center is at 0, 0. Okay, b is always under y. So b equals 4, right? We always take the square root of that number. And a is equal to 5. Okay, so I'm going to plot my center. And I'm going to count. Since 4 or 16 is under y, I need to count 4 up and down on the y-axis. So 1, 2, 3, 4, and 1, 2, 3, 4. And then I see 5 underneath the x, so I have to count left and right 5. 1, 2, 3, 4, 5, plot a point. 1, 2, 3, 4, 5, plot a point. So from these 4 points, you have to create a rectangle. Let me do that in purple. So I'm going kind of just making dots, creating this rectangle. You can kind of see it coming together. And with this rectangle, again, we have to draw our asymptotes. They always go through the corners of the rectangle through the center. And I'm going to make it nice and long so I could have a good graph. So through the diagonals, through the center. So I don't like that it's not going through both corners. So there's one asymptote. And then here's another asymptote, again, through the corners, through the center. And I see that now I'm subtracting x. So x and y are switched. So that means I'm like repelling the x-axis. So my graphs are going away from the x-axis. So I know that the light purple ones, since it's opening up and down, are actually going to be my vertices. So I'm going to follow my asymptote to create half of my hyperbola. Again, the asymptote is just a guide of what your graph looks like, but make sure it's going through your vertex and never crossing the asymptote. Okay, so my one vertex is at 0, -4. And then my other one is at 4, 0. And then we don't worry about these because my hyperbola is not going through those 2 points, so those technically are not my vertices. Okay. All right, let's see some examples where our center is no longer at 0, 0. So number 3, I see something actually being subtracted from x. So my center is going to be, again, it's still like the opposite, just like an ellipse, just like vertex form for a parabola. This is going to be at 2, and since nothing's being subtracted from y, that's 0. So 2, 0. So here I know that a is going to be 3 because I took the square root of 9, and b is going to equal 5. So again, my center's at 2, 0. And I have to count. So 3, where the 9 is under the x, so that means I'm counting left and right 3. So 1, 2, 3, 1, 2, 3. And then I have to count, let me do this in the light purple. I'll do this. Okay, and then since the 5 is underneath the y, that means I'm counting up and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we have to create a rectangle. So be careful when you're making this. So kind of just make sure you're in line with the dots. Okay, and again, to create my asymptotes, it's going through the corners of the rectangle through the center. Let's make them nice and long so I can have longer graphs. And then this one. So there's my asymptotes. And let's see which one of these is going to be my vertices. Is it going to be the dark purple or the magenta? Well, it's subtracting y, so it's going opposite of the y-axis. So that means it's opening left and right. So these dark purple ones are going to act as my vertices. And I'm going to follow this asymptote all the way through. I'm going to do it again on the other side. So one vertex is at 5, 0, and -1, 0. Again, those other points just kind of act as a guide to create my rectangle, which in turn create my asymptotes. Okay, number 4. So when you're identifying your center, be careful. Whatever number's with your x is the x coordinate of your vertex. So it's not just whatever number comes first is the x-coordinate of your vertex. This is with x, so that's the x in my center. Sorry, I meant center, not your vertex. So my center x-coordinate is -1 because that's with the x, and the y-coordinate is going to be -3. Again, it's the opposite of what you would think, even though they're in a different order. If it's with x, it's your x-coordinate. If it's with y, it's with your y-coordinate. Okay, so we know that b always is with y, so b is equal to 2. If you forget the variables, that's okay in this situation. Just know that you're moving along the y-axis 2, and then you're going to move along the x-axis 4, because we take the square root of that denominator. Okay, so my center's at -1, -3. And then I'm going to count along the y-axis, which is up and down, 2 up and down. So 1, 2, there's my point, 1, 2, there's my point. And I'm going to do the same thing for the x-axis. So since 16 is underneath x, that means I'm moving 4 along the x, so left and right from the center. So from the center, I'm going to go 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the left. And now I'm going to create my rectangle. So just follow these points that you made as a guide. And then we have to create our asymptotes by going through the center and the opposite corners of your rectangle. That didn't go well. Okay, and then we could go this way. That one didn't go well either. There we go, it's a little bit better. Okay, and let's see. Since we are subtracting x, we are going opposite of the x-axis, so that means my parabolas are opening up and down. So these light purple ones are going to be my vertices. So use your asymptote as a guide through the vertex. I'm going to do the same thing the other way. And there's your hyperbola. Okay, last one, number 5. My center is at 1, -2. Now this may look confusing, but it's pretty easy. I know that my A is going to be 4, and when you first see this, you may think, well, how am I going to move along the y-axis? Well, technically, there's an invisible 1 there. Okay, so when you don't see a denominator, just like when you see like a whole number, you know the denominator is 1. And the square root of 1 is 1. So I know along the y-axis, I'm only going to be moving 1 spot. So my center is at 1, -2. And then I'm going to count 4 along the x because it's underneath the x. So you're going to go from the center, 1, 2, 3, 4. And then from the center, you're going to go left, 1, 2, 3, 4. And then I'm going to do the same thing for the y, but now I'm going up 1 and down 1. So I have a small little rectangle right here that I'm creating with those points I just counted. Okay, remember that our rectangle goes through, or our asymptotes go through the corners of our rectangle and the center. Oh geez, I'm so bad at this. Sorry guys. And you could extend this on Notability. It's pretty easy. Kind of does it for you. Okay, and then I'm going to do the same thing the other way. goodness, sorry guys. I extend this a little bit. Okay, and now let's determine which one's my vertices, the dark purple or the light purple. So I know which way they open. Well, we are subtracting y, so it's kind of repelling the y-axis. So that means they're opening left and right. So the dark purple are going to act as my vertices, and I'm going to use the asymptotes as a guide. I'm going to do the same thing on the other side. And there you go. There's your hyperbola. Okay, and that's it. So, again, when you get into senior year, you're going to learn about the foci of a hyperbola and go into different parts of the hyperbola, ellipses, and go more in depth into these. But this is kind of the most basic form of how to graph them. But that is it. Congratulations, you are done. This is your final lesson of Algebra 2. Yay!